Welcome to another edition of Comet Algebra. This is Algebra 2, Chapter 2, Section 2. Wow, 222. All right. Linear equations. Again, review from Algebra 1. First, a term, standard form. When we write something in standard form, it is written ax plus by plus c, where a, b, and c are integers, not fractions, not decimals. And not only that, the leading coefficient, meaning the coefficient on the x term, a is positive. So this first example is an equation written in standard form. We have the x term, the y term, the equal sign, and then the number. And we are asked to change this to function notation. And so you're sort of thinking function notation looks like this, f of x or g of x or whatever name you choose. And you don't see an f of x in here. But then we recall from our notes from 2.1 that f of x is the same thing and is interchangeable, same thing as y. So our strategy could be, if we solve this for y, then we can write it in function notation. So I start solving it for y by subtracting a 2x from both sides. Next, we divide everything, and I mean everything. All three terms have to be divided by 3, and then we get y equals negative 2/3 x plus 2. Now this is in y equals. Now I can take out this y and put in the f of x. It is now in function notation. Using this same example in standard form, now we are asked to find the x-intercept and the y-intercept. So let's think about that for a moment, and we'll look at a picture over here of an xy axis and any line that is graphed anywhere through here, perfectly straight as always. Just so you know what the x-intercept is. The x-intercept is right there, right where it crosses the x-axis. Likewise, the y-intercept is where it crosses the y. And the key to finding these algebraically, now we will be able to graph them and look at our calc screen, but if the intercept falls in between two integers, it's difficult to see accurately. So we need to know this method also. Right here, right where the line crosses the x-axis, right at that point, y, we come over here, x, y, we're not going up and down at all, so y is 0. Likewise, right here, where it crosses the where it crosses the y-axis, that's where x is 0. So we use this fact to write down the strategy here, how to find each intercept. So stating the strategy here, to find the x-intercept, set y equal to 0 and solve for x. To find the y-intercept, vice versa of that, set x equal to 0 and solve for y. Now I picked an easy one here for doing the math. So first, to find the x-intercept, can you picture putting the 0 right in there for y? So I have 2x plus, well, 3 times 0 is 0, equals 6. Divide both sides by 2, and the x-intercept is 3. So you can write that as x equals 3, or you can write it as an ordered pair of 3, 0. Don't just write 3. Be sure to say either x is 3 or a location on the graph. Then the y-intercept, put the 0 in for the x, and you'd have 0 plus 3y equals 6, and y equals 2. That's fine to state the y-intercept that way, or you could write it 0, 2. Next is a review of what we called the slope-intercept form in Algebra 1. Should be very familiar to you. Y equals mx plus b, where m is the slope and b is the y-intercept. First example, we are asked to change this equation, which is given to us in standard form, and they would like us to change it to slope-intercept form, and we know that means it's the y equals form of the line. So we subtract a 2x from both sides, and I'm in the habit of putting the x term first because I'm very used to working with mx plus b. And again, we divide everything by 5, which means we do get a fraction here. And don't forget to divide the 20 by 5 also to get the plus 4. All right, a review of slope is next. We can define the slope to be the rate of change. And this has so many applications in real life that we've talked about some of them in class. Change can be increase. If the slope is increasing, it's a positive slope. The slope could be decreasing, could be a negative slope. In words, we would say that slope is the rise over the run. And then algebraically, how we find it is this y. All right, totally a typo here. Don't know how that happened. These should not be plus signs, so let's just fix this. So I'm just going to kind of cross this out. This should be y minus y, y2 minus y1 over x2 minus x1. So forget this. This is the right one. Y minus y over x minus x. We want to find out how much the y's are changing, which is the rise, how much this is changing when it's going up, and over the x change, which is how much it's going across the run. So we're asked to do this example, find the slope of a line that passes through this point and this point. Now it doesn't matter which one you call x1, y1, and which one you call x2, y2, as long as you're consistent in the one that you start with. So I guess for this example, I'll just call this one x1, y1, and this one x2, y2. It wouldn't matter, you'll still get the same answer either way you set this up. But please remember, the y's go on top. It's human nature to try to always put the x's on top because it comes first in the alphabet. So we have 5 minus a negative 3. And since I started with the 5 here, I must start with the x term that goes with it. So I must start with the negative 8. And we will be subtracting a 4. So then doing the math, double negative becomes positive. So I get 8 on top. A negative 8 minus 4 is a negative 12. And then please do reduce your fraction to negative 2/3. Another way we need to be able to find the slope of a line is simply by counting it. Now this diagram is not fabulous for showing the intersections on graph paper because I don't have all the lines for the grid drawn on here. But what I'm trying to show you is that you look for intersections in the graph. Like this line, this red line crosses the intersection at -5, -6. And then when you follow the line, right here, see these are not intersections. And then right here, the red line crosses another intersection on the graph. And so we can count from intersection to intersection. So I found one here, I found one here. So we're going up 2 and over 3, up 2 and over 3, up 2 and over 3. So this slope happens to be rise is 2, run is 3, 2/3, and we know that it's positive. So just another way of finding the slope on the line, you can count it from the graph. All right, let's look at these diagrams next just to help us visualize what positive and negative slope look like. When we read slope, we read it like we do the English language. we go from left to right. Reading a positive slope, if you could picture yourself, you're walking on this line, you're walking uphill from left to right. A negative slope would be us walking downhill from left to right. A horizontal line, like for instance, if we are 2 units up here, y can only be a positive 2. X could be over here at 50, but we're up 2. X could be over here at negative 25, we're up 2. So this particular horizontal line I drew here is y equals 2. And if we picture ourselves walking along this, it's like walking on flat prairie. This slope is 0. Because the rise, it's not going up at all. The rise is 0, the run is infinity, and 0 over infinity is 0. However, it's very different here when we have a vertical line. This vertical line, if I've gone negative 2 units over here, x is a negative 2, y could be up here at 50 or down here at negative 400, but the x is always negative 2. That gives us a vertical line, and the rise is infinity, and the run, it does not go side to side at all, so infinity over 0 does not work in our number system. So we say that any vertical line has no slope. Another way we say that is that the slope is undefined. And again, that comes from the fact that we cannot divide by 0 in our number system. All right, this is the last example we're going to look at. We are given a line in standard form. We are asked to write it in function notation and then use the slope and y-intercept to graph it. So let's just do the first part. Again, function notation, we need to solve for y. So subtract the 3x from both sides, and then divide everything by 2. So I have negative 3/2 x plus 4. And then to put it in function notation, I simply take out the y and put in the f of x. Now to review, using this slope and y-intercept to graph it. So I drew an x and y axis to work on. Someday I'm going to figure out how to put a piece of graph paper here. Give me something to work on. So to recall from Algebra 1, this 4 is the b, which is the y-intercept. So we come over here and we count, it's a positive 4, so we count up 4 on the y-axis and put a dot. This is the y-intercept, so that is going to be our starting point. Then we see the number in front of the x, which we call the m, is the slope, and it's a negative 3 over 2. So we can picture that the line is going to be running downhill from left to right, and so we count down and over. So this is down 3 and over 2, and we put a point. Then go down 3 and over 2 and put a point. Down 3 and over 2 and put a point. And of course this would look just fabulous on graph paper. And then we connect to the dots that we made by counting our slope. And that's how we graph a line when it's in the slope-intercept form. All right, now you have the knowledge you need for section 2.3. Sorry, 2.2. Have fun with that.